Okay, so what we did on Monday is we put this in the form y equals mx plus b. We found the two slopes and we found that they're perpendicular. So now what we're going to do is graph. So when you're looking at your line, you're going to find your y-intercept. So this is at 2. Now if your slope is 7, remember that the rise over run, you put this over 1. So you're going to go up 7 and then over 1. And then you're going to go down 7, 1, 2, 3, 4, 5, 6, 7, and then back 1. And then we're going to connect that with our straight edge. And I will pass those out to you so that you have them. Okay? And then the next one, I want you to graph this one. So you're going to start at 2. And negative 1 over 7, and then we're going to check that. And I know some of you are ahead, that's awesome. If you can just check with the stuff that you have. We'll do that when we have it. That's a blank one, so you can jump in with us. Okay, so your starting point is actually going to be the same for this one, so it's going to be 2. Okay, you always start on the y-axis, and then if it's negative, you're going to go down 1 over 7, and then you can go up 1, and then you have to go to the left. So if you go up 1 first, then you have to go to the left. Okay, now remember, perpendicular lines, when we talked about the definition on Monday, we talked about how they're going to meet to form right angles. So some of you are already doing a nice job of recognizing if you got perpendicular, if they don't look like they meet to form a right angle at the corner, then we're going to recheck that. Okay? So it should be an exact T. So if I tilted my paper, see how that's going to be a 90-degree angle? And then if it's perpendicular, we can put the little square. Okay, so now we're gonna do part C together. Now some of you already tried this, and I was actually really impressed that some of you did your distribution and you put that in the form y equals mx plus b. That is so awesome. Okay, what we talked about yesterday was what you want to do is you want to find the slopes of each line. So anytime you're trying to find the slope, you can always look in front of your x. Okay, so if it's in that form, y equals mx plus b, you can go ahead and do that right away. Now, because that's in the form y equals mx plus b, why don't we go ahead and graph that before we start the next one? So if it's in the form y equals mx plus b, you're going to start at b. Okay, so Keith, for this one, can you tell me what my b value is for the y-intercept? Yes, good. Okay, so we're going to put our point at 3. Nice work. And then if my slope is negative 1 over 2, the negative means I'm going to go down, and then I'm going to go 2 to the right. So down 1 over 2. Okay, so can you keep doing that pattern until you get to the edge of your paper? And then we're going to do the opposite direction, so up 1 over 2. Up 1 over 2. And then we're going to use our straight edge to connect our points. Okay, now when we're trying to decide if it is perpendicular, parallel, or neither, remember from yesterday, and I have this on the board, if they're parallel, the slopes are the same, and then if they're perpendicular, when you multiply them, you'll get negative 1. So we are going to put this in the form y equals mx plus b. You can absolutely do that. But you actually know what your m value is because this is point slope form. So this is y minus y1 equals m x minus x1. Will you guys write that above because that's going to be helpful for the next step. And there are a couple different ways that you can do part C. Okay, so can anybody tell me what the slope is for this line? Just by looking at it there? Yep, it's 2. So right here. Okay, so then your slope is 2. So obviously they're not the same. Okay, if the slopes aren't the same, the next thing you're going to do is find the product. So this is what you're going to ask yourself. Are the slopes the same? Okay, no. Then you're going to find the product and see if that equals negative 1. I like the sound of those calculators coming out because that's exactly what we're going to do. So we're going to multiply negative 1/2 times 2. So remember yesterday we talked about how you can always use your parentheses here. And then look, it equals negative 1. So what does that mean? Yep, it's perpendicular. Okay, so is the product negative 1? Yes. What if it wasn't? What would I write as my answer? Neither. Great. Yeah, you guys did a really nice job yesterday. Do you feel like you're getting the hang of whether it's parallel, perpendicular, or neither after yesterday? Because we did do a lot of that. Okay, so we know that this line has to cross it and it will form right angles. Now there's 2 ways you can do this. So like I said, I was really impressed that you guys remembered what we did in the last section and you guys did an awesome job of distributing. So you had y minus 2 is equal to, and Joey, I noticed you did this part already, right?
Yeah.
Where you did that, can you tell me what you got on this side? Great. Okay, and Avery, I think you did this too. So when you got here, what did you do to get y by itself? Yep, good. You got to add the 2 to both sides. Okay, so that's in a form where we can graph by starting at the y-intercept. Okay, so Ryan, can you tell me what the y-intercept is of this line? where my starting point's going to be. You are right. Okay, so you're going to start at 6. And then anytime your slope is a whole number, remember that when you're graphing, you just have to put it under 1. So you can go up 2 and then right 1. If you go down 2, then you have to go to the left. Down 2, go to the left. Down 2, go to the left. Okay, and then once you connect those, they should form a right angle. So if you notice that you cross them and it does not form a right angle, then we want to go back and double check that. Because I saw a couple of you didn't graph that correctly. And now we can see that they're perpendicular. Okay, and then while some of you are still completing that, I told you that there was another way that you could do this. The other way that you can do this, and this is what we're going to use for D, is you can pick out a point from your equation. Okay? So remember that your form is y minus y1. So if you have y minus 2, your y1 is equal to 2. Now this part is the tricky part. If it's plus 2, okay, then that means your x1 is negative 2 when you take it out. And we'll talk about why. You don't necessarily have to write this part down, but when you are taking your equation, you have the minus value here. This is a minus negative 2. Remember when we set up the equations, when we had minus and negative, what did we always have to do to simplify it? Yeah, we turned it into a positive, so that's all you see is the positive. So when you pull it out, you could start at this point. Okay, so you could start here instead of your y-intercept. So if you look at negative 2, 2, do you see how that's a point on your line? Right here. And that's what we're going to do for part D. Okay, and the reason why is some of you who've already simplified this saw that, what was your y-intercept for part D?
29.
Yeah, good. You'd get 29, and then the reason why we wouldn't want to do that is because there's no 29 on our graph. So we're going to pick a different point. Okay? Okay, so we're going to start this the same way as the last one. So your first line is already in the proper form. Okay, and then Gabe, can you tell me my slope and my y-intercept for this first line? Yep. Good. Yep, so 4 is my slope, and then negative 5 is my y-intercept. Okay, so if I'm starting at negative 5, I'm going to put my point there. And then can you guys use the slope to finish that line and connect it? Now that you've seen me do it a couple of times with a whole number. Because you put it over 1. So start at negative 5. We're going to go up 4 and then right 1. Up 4, right 1. Now, if you know your slope is positive, remember that your line should be going up from left to right. And if you have a negative slope, it should be going down. So that's always something that you want to double check to make sure that you've graphed it correctly. Okay, and now in the second one, we're going to use this equation. Okay, and then Bree, for this one, can you tell me what your slope is? For in this form? Not in this form, you're not sure? So, yep, it's always in front of your parentheses in the point slope form. Yep. Okay, so are our slopes the same, 4 and 5? No, not the same. Okay, when I multiply them together, am I going to get -1? Well, 4 times 5 is 20. So no. Okay, so not the same. Product is not -1. So these are going to be neither parallel nor perpendicular. Okay, so when you are picking out your point, if there's a minus in front of this, okay, you just are going to pick out the positive. So your y1 is 4. And if it's positive, remember, that comes from minus a negative. So that's why your x1 is -5. So it's the opposite there. So that's a little bit tricky, because before we were plugging them in and we were doing the simplifying, but now we have to unsimplify that part. Okay, and then every point that you write, the x goes first, the y goes second. So we're going to start at -5, 4. Okay, so this is where you're going to start when you graph. Okay, so can you guys plot that point, -5, 4, and then we're going to use our slope. Okay, so this is your x value, so you should be counting -5 on the x, and then up 4 for the y. That's where you're going to start. Okay, so that's an alternate starting location instead of your y-intercept. And now you're just going to use your slope. So from there, if m is 5, you just have to go up 5, and then remember, the bottom number would be 1. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. Now these almost look parallel. Almost. That's because you have 4 and 5. So they are pretty close to each other. Okay, and then while you are finishing that, I'm going to show you what these look like on Desmos. And we're going to do some work with Desmos today.